Hello and welcome to another one of D's ADD videos. Today we're going to be discussing probability. What's the probability of flipping a coin and getting a head? Most people know that out of common sense. That's 50-50, right? Or 1/2. Well, the reason that that's so is because there's one head out of two possible choices, being heads or tails. So that's what probability is. The number of times your desired event occurs over the number of possible outcomes that can occur. So let's look at another example. Let's look at what is the probability of getting an ace out of a deck of cards. Well, those of you that don't know, there's a total of 52 cards, not including the jokers and the rule card. So there are 4 of each card, including the ace. Right? So if we were looking for this one, it would be 4 aces over 52 cards, which reduces down to 1 over 13 probability. Alright? Let's see, where do I want to go from here? Now, if we're looking at probability of independent events, they're disjoint. There's no intersection to these events. Right? Then the probability of A and B is written like this: A and B. The formal name for that right there is called the intersection. Would be the product of the two probabilities. And then probability of A or B would be the sum of the two probabilities. Alright, so let's look at a couple examples of that. Basic examples. So if I wanted the probability of getting 2 aces, the way we would write that is probability of an ace intersecting ace. I now have to do a quick side note. This would be with replacement. So that means after I take one card out, then I put it back in the deck and pull the second card. Alright? And I'll show you how it differs without replacement. So probability of ace and ace would be 1 out of 13 for each of those. Always doing the answer in a different color. I should have stuck with black. It's a rough draft video. I will be re-recording this, so I apologize if I make a mistake. It is 2 o'clock in the morning, so here we have 1/13 for the probability of one ace. It would be the probability of ace times the probability of ace again. So that would be times 1/13, which is 1 over 169. Alright? Now, if I didn't replace it, what would happen is we would have the first probability be 1 out of 13 because there's 4 aces in the deck, but then the next one would be what? 3 out of 51 cards left in the deck. And there's 3 total aces. And I left my calculator in the other room, so you guys are going to have to do this calculation on your own. But that would be the probability with replacement. That is putting the ace back in the deck of cards, or without replacement, sorry. Not putting the ace back in the deck of cards after you pull the first card. Alright? So for the OR example, what's the probability of pulling an ace or a king? So with replacement, the probability of each of those will be 1 out of 13. But before I get to that, I should do the general formula, which is the probability of ace plus the probability of king. Right? So 1/13 plus 1/13 equals 2/13. So then probability without replacement, my color usage is all over the place, huh? Normally it's a little bit better than this, I apologize. But here we have the first one would be 1 out of 13, right? But now there's only one card been taken out, so the denominator is going to be 51. But the kings haven't been altered. There's still 4 kings in the deck. So that's the number of kings. And this is 51 because we took out a card. Right here. Okay. And it would be the same either way. If you pulled out the first king, if you want to say that this is the king or the ace, then if you switch around, the scenarios would be the same. Alright. So, if there is an intersection, what happens? Well, if there is an intersection of the two events, if they're not mutually exclusive, and they're, when we're calculating this, this is my last video, I think, getting tired. Probability of A and B would be probability of A plus the probability of B minus the probability of A, B, B. Alright? So know this formula, and these two are interchangeable, and you will be given 3 out of the 4 parts to this puzzle, and you can then solve for the 4th. This has clarified the basic rules of probability. Again, quick recap. Number of times your desired event occurs over the number of possible outcomes. Then you do the probability of independent events are going to be the product of these events if we're doing the intersection. And I never wrote what this one was. This one is called the union of events, and it's summation for that one. You add the probabilities, and that we looked at with replacement and without replacement. Basically, as the name implies, with replacement you would put it back into the pool of choices after you started and did your first try, and then without replacement you would not put it back in the pool. Alright, hope this is clarified. Any questions that you might have about basic probability, make sure you practice, and